I had a really good weekend. I spent 20 hours teaching, Saturday and Sunday. Yeah, I was teaching a project management class. That was really cool. We talked about how to create positive environments in a workplace. We went through creating emotion maps. How you start with a positive environment and use negative controls. Or if you have a very negative environment, you use positive control. It's pretty good. Good stuff. I would recommend you guys take those classes. They're good. Every engineer should know how to run their project.
Are they only offered on the weekends?
And I do it for a reason. Because I'm only available on weekends.
Oh.
I'm not saying that because I am available. It's just that when you have a 10-hour workday, that's how project managers are, right, in the workplace. So you get to practice to work for 10 hours and still smile at the end of the day. You spend 10 hours, right? Your project manager still expects you to smile, right? So it's practicing now, basically. And plus, you don't get any homework. It's all in class. And 3 weekends and you're done. Maybe I could make it 52 weekend long class, but that would be horrible.
3 weekends.
For me and for you guys. But it's only 3 weekends. Okay. Assignment 336B. You guys remember all this? You guys can't even see that, can you? Okay. Now you can. And if you can't, then what I'll do is, I'll need to write some notes. How do you become a Java group? You write lots of programs in Java. Assignment 3 is about opening a text file and printing some data, sales data. Right? So we created, to do this, we created, and I'm typing this because you guys can't see things in Eclipse because the font size is too small for the stuff on the left side. So we have a program called driver.java. We have a class called driver.java that will be the driver that will have the main. We will have file.io.java that I'll write for you guys, right? That is just free, given to you, and it should work, hopefully. You are recording that, aren't you? Oh man, you have to be perfect. So this will read the file and populate populate data in Panther. And then what? Then you have franchise and store. Franchise.java has, I don't know what franchise.java has. It has stores. It has an array of stores. And then, and store has calculations. Right? Driver, no, store.java. That's it. So. Oh, it also has a two-dimensional array. So that's only for personal use, right? The video, we're not gonna post it anywhere? Okay. That's perfectly fine. But I'll also strive for perfect code because it shouldn't be anything else but perfect. There's a bit of a problem here, no? What is this 2D array? What is 5 and 7?
Columns, 7 rows.
5 weeks.
5 weeks, 7 days per week. Very nice. So this is our context. Now, to help you guys with reading a text file, and some of you say that you didn't work on this in 36A, so it's going to be a bit of a review. And Chrome is taking a while to start. So we just have to wait. Maybe I can start Mozilla, but that might be faster. Oh, nice. And where are we?
73.
Material content for 36B, you'll find a link here, assignment 3, help reading data from text files. That's basically pointing to my material from 36A. And when you go there, it has a ton of notes, good bedtime reading. But there's a thing in the bottom that's called readsource.java, just open that. And that's what we're going to be using. And I'm going to drop this in Eclipse. See, Chrome finally came up. I actually like Chrome when it works. It just takes a long time to come up. So here is file IO, and we have a function that will return, so public franchise read data and string file name and begin and end. And backslash is an invalid character. The method must return a result franchise. Okay, fine. So we will make a franchise. And how do you make a franchise object? New franchise. And is that it? What? I don't know. I will. Yeah, I guess. So I can say number of stores here. So I have that constructor. And what else were you saying? That's my constructor, number of stores. So I'll build an array of stores. And I should also have a, do I want a default constructor here? So I make like, that'll make a one-dimensional array of stores as null by default. Is that a good idea or a bad idea?
Bad idea.
So we don't want to have a default constructor. We just want to allow it, right? If anybody during this construction process gets lost on anything, you have the full right to stop me, because I'm not being recorded for public presentation today. In fact, you're allowed to, of course, interrupt me anytime you want. Yes.
Is there any way to transmit a message to the console before creating a class? Say like this class requires these arguments, like before a constructor even in a class. Like have a public class and then say before you do anything, before you create an object or anything like that, I'll put this message and then go through everything.
Yes. Offline. Short answer, reflections. There's a topic called reflections that is covered in advanced Java that can be used with a bunch of static graphics. That's never done though, even for being helpful, because the run times are usually applications.
Right, yeah, so then you wouldn't
Right.
really need someone to generate music.
You check the API documentation.
Yeah. I was just curious, like if it was
Yeah, sure. No, good question. Okay. So I'm going to say how many stores. In fact, you know what? Why don't we read that from the file? How many rows do I have? I have 6 stores, right? So when we are reading this file, we are going to just make sure we do it right. Meaning if we say 6 stores, then we'll have data for 6 stores. In advanced Java, we'll have more fun and say, oh, 6 stores, but I'll really give you 5. And then we'll have some defensive coding to manage that, right? But we're not kind of ready for that yet. You're like, what? Why not? I know if statements. Why can't I tackle that? Sure, with if statements you can, but it's better with exceptions. So, each lab has an objective, so we'll just focus on that and just get better at things over time. So I'm going to take this, the location of the file, right? So let me go into file IO and I'm going to create, I'm going to use this constructor later. So I'll put in 6 for now, but I really want, what I want to do is read that from a file and populate. So now the whole song and dance begins with reading a file, getting the number 6, and putting it in the right place, which is what you guys want to know. Okay? So let's look at this file. Just let's try and understand what's going on. How many of you have never heard of, how many of you have like never done file IO in your life? Okay. Okay, so then I guess the life for file IO begins. So then I have to tell you a little more detailed story, right? So you have your operating system, which manages hardware, and here is your Java program. Actually, no, I lied. This is your Java virtual machine, and floating in there is your Java program. Yes? Pretty simple. Your hardware, there is a place to store files. And I want to call it place to store files because you've got different mediums, you know. So this is your storage, and you have your file called abc.txt. And your goal is to open this file in your Java program, right? So there are some underpinnings that are important to understand. When files are stored in the operating system or on any operating system, there is the thing called the file system. You've probably heard of things like FAT32, Unix file system, high performance file system, which was for OS2. What is Mac file system called?
NTFS?
Huh?
Oh no, I'm sorry. I thought
NTFS is Windows. Let's call it the Apple file system. But when we talk about a file system, what are we talking about? We're basically talking about a database, right? And it basically contains file information. So I'll have a file ID, and then I'll have lots of properties for the file, like size of the file, where it's located, attributes, is the file ready to be opened, is it archived, can I write to the file, who has opened the file, when was it last modified, blah, when was it created. And usually when you go and look at the proper, like, you know, if you hit Alt Enter in Windows and look at the look at any file, that's file properties, right? And that information is stored in this file system. Now, whenever you go from Microsoft Word, Excel, PowerPoint, or whatever, you create a new file, an entry goes in the file system, and then it's written to storage. And that way, multiple applications or multiple processes, when any of the process needs to access it, always refers to the file system. Because sometimes you cannot have two processes opening the file at the same time. And that thing is prevented by the file system. Why am I covering all this? Well, if you're working with files, you should know all this, right? They're like things that nobody asks, but you must know. Okay, so now I'm ready to open a file from Java, from a Java program. So I'm going to make an object, A1. I don't know, I like variable name A1, so save it. So we're going to open a file. So we are going to use java.io.start. That's a predefined package for doing input-output. That package, folks, it has objects and methods to read text files, binary files, and many other kinds of files. It's ones you don't want to know right now, but you might want to know later. Okay? So today we are only worried about text files. So text files, there are two classes, file reader for reading and file writer for writing. So if I want to open a file to write data, it's one-way street. Then I use file writer class. If I want to read data, I'm going to use file reader. So if a file already exists, which is what we're doing now, we're going to open the file using the file reader class. And file reader class is very easy. We will say file reader A1 equals new file reader abc.txt. So this guy makes an object in the memory of the program. It's called A1, right? And by virtue of that one line of code, which is, because my writing is so bad, it's there, but we'll also type it. We open the file for reading, so we can start pulling in data. So this line, what it does is it says to the JVM, hey, I want to open a file. JVM says to the operating system, I want to open a file. Operating system says to the file system, do you have the file I want to open? abc.txt. Oh yes, I do. Where is it? Somewhere in the storage. So this is all internal to the OS. It says, okay, yeah, I found the file, I have it. And here is the location, by the way. Let's say this is the file ID, right? So this identifier gets passed to this object, right? So So if A1 is equal to null, that means what? Nothing, right? If A1 is a non-null value, I got the file. Now there is one other thing that Java does, which is exceptional than C++, right? It throws an exception. That's what is exceptional about Java. What is an exception? So in life, sorry, go ahead. In life, two types of things can go wrong, right? Something goes wrong and you can't recover from it. And then there are things going wrong and you can recover, right? One is called an error. You can't recover from error. But if an exception occurs, you can recover, right? So, this is built in the Java virtual machine. And then there are some exceptions that JVM knows about. And there are some exceptions that happen that it doesn't know about. So problems that occur in runtime that are not known because they will happen based on the quality of code you wrote, right? So when A1 is null, right, it won't tell you A1 is null. It will actually say, it'll be more comprehensive and it will say, you know what, file not found exception. So one of the things that you guys are going to be learning eventually is how to do defensive coding. I will touch on that in this course later on, but instead of saying this, it will throw this. That's why, bless you, you're going to see some code around exceptions, right? And I didn't want you guys feeling surprised that, gosh, what is this, right? For now, we'll just use a simple technique in the code so we can deal with exceptions. And that is why we use you're going to see a try block. So what we are saying is, when we know something can go wrong, let's go ahead and try it. If it succeeds, great. And if it doesn't succeed, let's catch the problem. Right? Which is what you guys are doing too when taking this course, right? Success is imminent if you do all the labs, and success is imminent if there are no exceptions. There, nicely put, right? You do all the labs, you get an A in the midterm, you get an A in the final, boom, you got an A. But if there is an exception, right, then you got to catch that and say, oh, okay, what happened? And right now, we will only sympathize with that exception. Oops, problem occurred, right? I cannot open the file. Oh, I caught it, great, and my program died. That's not how things should be. The way things should be is, well, I could not open the file, let me go ahead and retry. And keep doing that until I am able to open the file. Right? That way, if we can create software that heals itself, that fixes itself, that's like the best kind, right? That has to do with software quality and some other things that we'll cover in the future. But for today, as you're learning about file I/O, the way the API is set, it forces me to cover two topics concurrently. One, how to work with files, right? How to open a file, how to read a row, how to split it, using the split function, which I think you guys know in strings, and then how to save it in an object. Right? That's one piece of the puzzle. The other piece of the puzzle is how do you open the file and if an exception occurs? Because when I start throwing things like try and catch, at an elementary level, I need you guys to know what it is. And that's what we are doing right now, right? So to step back and talk about problems, there are two types of problems in life that can occur. Ones that you recover from, the ones that you cannot. The ones you cannot recover from are errors. And there are no errors written here. Now there is. Not trying to make this a philosophy class. Or you can have exceptions that you can recover from. JVM knows about some exceptions. It says, if I work with files, this can go wrong, right? That's where, when we are working with text files, it knows all that can go wrong. And that is called a checked exception. I know that can go wrong. Are there things in your life that you know how to respond to if things go wrong because you have dealt with it before? That's a checked exception, right? If there are new experiences you're gonna have in the future and you don't know how to deal with those are unchecked exceptions. Get it? That's why I like my physical world and the world I live in, because it's so object oriented. It's like I'm living in a Java virtual machine. Right? The problems JVM knows about, checked. The ones that I'll create with the future software I'll write, unchecked. It's very simple. So whenever there is a checked exception, I must use a try and catch. And this is a good thing to, if you're trying out something, try it. If something goes wrong, then catch. Right? So software engineering has taught me a lot too. Like as I've been learning Java, just try, catch, then fix, and try again until you get it. And then you have loops, right? So it works out pretty well. Okay. So I can actually program my entire life in Java now because of Trycatch. Okay, so if you get this idea, I'm ready to jump to the code snippet. Yes?
Do we need to use try and catch every time when we use text file?
Yes, always, because it's a checked exception. Any other questions? Yes?
You have to put anything inside of the brackets and then catch for?
Here? Yeah, here we will say there is a, like what type of problem?
So then if
Very good question.
If you want to check for multiple problems, you have to...
You have multiple catches, right? And right now we'll just deal with one problem, exception. If you want to tackle each problem differently, then you'll have a very long program, right? Right now, let's just sympathize with the problem. Oops, sorry, that's it. And I'll show you how to do that in a minute.
So does exception usually take you back to the previous method?
No, you have to work on that yourself.
Redo it, or it skips that methods and goes on the next one?
Correct, yeah. So when we are in the try block, if let's say I have 3 lines of code and things broke at line number 2, right? It's going to stop right there and it's going to say, oh, problem occurred. I'll go into the catch block. I'll execute all this code and get out or do whatever is next. So it's not going to go back and fix the issue, but that's the ownership of the developer.
So you're pretty much giving it 2 options to the programmer. The first one does not work, go to the catch.
Yeah, your program basically doesn't crash, and that's why you have a catch. And you can choose to do nothing, or you can choose to do something. Our politicians implement Trycatch a lot. But the catch is like, you know, I won't say anything. I'm being recorded.
So if you did a try-catch where we were just looking for a file, right? And then in the catch you just said like exit the program, just
Yep.
something like that. Then how would that really benefit you? Because if you couldn't find the file, then it would just crash, and if it couldn't find the file this way, it'll just exit the program. So like how I'm just like this.
Well, it is a graceful exit, right? For now.
Yeah.
Rather than print some very encrypted message, you can print a user-friendly message. I'm so sorry, the program crashed because I was not able to read the file. Please try again with the right file name.
So it's more for like UI.
Yeah, user experience. It's very important in software, right? And that's something that I'd like to draw your attention to also more and more as you start writing your lab assignments, that focusing on user experience is your responsibility. And the earlier you start, the better. So, yes?
Is that the same as a if, else?
Yeah,
Yeah?
it is.
With the catch.
But then the question is, why is it different? Why do we have a try-catch when we have the if statement? You have the answer?
Because in an if-else statement, if both of them fails, the program will crash. You try and catch will just continue on.
An if statement, you have to know the problem at compile time, right? With try-catch, you can deal with it in runtime.
Yeah, there's no condition except for
Right.
catch.
Correct.
Is it possible to make it so that the catch part attempts to rectify the error? Like
Oh,
if
sure.
you have a file not found error, you can try to
Yes.
find the file in different locations.
Yes, yes. You just have to, next quarter. Or later this quarter when I get into more details with exceptions, if I have time. But you're so right, because that is the intention, and your neighbor is also asking the same question, right? Now what's the point, right? Why don't you do something about the problem? Yeah, I just have you on hold. Any other questions? It's just stepwise, that's all. Hopefully not overwhelm you guys. But if you're ready, I'm ready to go. I'm ready to hit the gas pedal. Any question, any more? Ready for code snippets? Yes.
For the file reader,
Huh?
for the file reader, where should our data be in?
I'll cover it in when we start writing the code. So we'll go through I'm gonna go through the whole process of opening the file, reading tokens, and building an object. And I'm gonna write that complete code in front of you guys. So, yes.
The scanner object also has a file reader, right? So I was just, I know there's different types of, other than file reader, there's different objects that can also read files. Like, what are the nuanced differences between like different file readers? Is there any real, like if it's just a text file, can you use anything, or how does it, what are the differences between using different classes?
So we've got two in focus right now: scanner and file reader. So file reader has limited functionality in that it has functions that will return strings only, and then you have to use functions to do the data type conversion. Scanner, on the other hand, has functions already built, right?
So this teaches you more?
Huh?
So this is like to teach you more?
No, this is just yeah, I guess you could say that. You know. Yes.
So can you read from files that are other than text files, like PDFs or Word documents?
Oh yeah.
Will you run into corruption issues or something like that?
Well, you have to understand the format of the file that you're reading. And so if you're trying to read a PDF, there are PDF readers. So like Adobe will have APIs. They'll not, maybe, I don't know if PDF API is part of Java library, but you can look for Adobe API to read PDFs.
Also, it's like special libraries that can
Yeah,
read from
right.
different formats.
Right, every file format you're interested in, right? Looks like you guys are working on some project. smart questions. They're running into problems, right? Okay, good questions. I like them. Any others? Okay. So, look at this. So, oh, one thing I forgot. When I open the file, that creates a stream. So it connects the file to the object in memory. I should. Oh, wait. So couple of more little things. So this is linked to this file directly, and this is the string. So stream is a sequence of bytes, right? So it's like opening a connection to the file, so I can either start reading data or write data, depending on if I'm using file reader or file writer. And there is also a buffer that can be added. And the code actually does that. The purpose of the buffer is what? So I can read a chunk and taxi it for reading by the program in a small memory location. You all know the importance of buffers, right? Or no? Okay, so let's say if we were going to move everything out of this room into a truck for moving, right? And I used to explain buffers like this long time ago. Where did my eraser go? I hope this makes sense. So here is the room, and here is the truck, right? So one way we could do is like pick up one article and go and place it in the truck. But let's say we have a lot of power of humans to work together. Like all 30 of us are ready to pick up chairs and tables and computers and whatever there is. Not that we're going to do that, right? Just because we're being recorded. We're not going to move anything, just explaining buffers. Makes it on YouTube, they say they're emptying out ADC 204. So we can create separate teams. So we'll create one unload team, we'll create a load team, and we will create a carry team. Do you get it? How the split is? So you can choose to be in one of these teams. So you can basically unload, meaning take stuff out of the room and put it into a temporary area. The carry team will take it from A to B, and load will take it from B and load it. So these are like little buffers, staging areas, right? Now if it turns out that these guys are really fast, the unload team is really fast, they can fill the buffer and go home. Then these guys can work at their speed, right? So buffers are like these staging areas. And what it does is, it allows these different computer systems, the truck or the, as a metaphor, or the room as a metaphor, it allows for high performance. So buffers improve performance. Because usually I say, oh, buffer is a temporary memory location and it improves performance. People say, what do you mean? Why would it improve performance, right? So this example, does it clarify how? Because you have different operating speeds, and this happens in computer systems all the time. You've got your processor, you've got the memory, you've got the hard drive, and you've got the registers or the cache, right? All of these components are operating at different speeds. And how do you mediate the performance? Buffers, right? So buffers act as temporary memory cache or temporary memory for processing data. Okay? Ready to look at the code? All right. There we are. File reader. It opens a thing called file, creates an object called file, and it's going to read the file, whatever name you give it. And if the file is located in a specific directory, then I can give it that, then I can give it that directory. So in my case, I'm going to be reading the file in this directory. You guys will need to change this for your structure. And when you use backslashes for defining the fully qualified path, you need to put double backslashes. So that double backslash will convert to a single backslash. All right? So this will open the file, and we will take this object reference and we're going to pass it to buffer because we want to create this temporary buffer. Then we say while not end of file flag, we're just creating a Boolean variable. Then we say while not end of file, read a line. Right? I'm going to read the whole line till the end. Then if line is not equal to null, end of file is true, otherwise print the line. And this is where most of the action will happen. Now, I don't know if you guys noticed, but there is the try block. That's the start of the try block. This is the end of the try block. And then we say catch. We say catch, and we say IO exception. So there are all these predefined exceptions. I could have, I think for the purposes right now, I'll just say exception. Exception is like this parent exception, and you can use this for anything. And as you can see, I'm not going to do anything about this exception, other than say, sorry, the problem occurred. I call that sympathizing with the problem, right? Question?
So you have opened the buffer, the string.
Yes, buffered reader.
Do we need to close it?
No, not in Java. I can throw that away and it's nice, it's clean coding.
It does not like
Huh?
it does not like
A warning.
yeah, warning.
Well, you can ignore it. You should. Are we okay? Okay, so I'm going to go ahead and, plug this into my method. And obviously I'm not going to hard code this, I'm going to use what? File name, right? Whenever you read files, you have to import java.io.start. Now, why does he have a problem? Oh, yeah, return. So I'm going to build my franchise object later, but I will go ahead and declare it as null. And because I just like to kind of have the code neat and tidy, I'll just say return, what was it, A1? Yeah. And you guys know about code cleanup, right? Just Control Shift F. Oh. That font size is too large. I can hardly fit any code. But it's visible to you guys, so that's good.
What does Control Shift F do?
It auto formats. So let's say I have a bad habit of, you know, doing this kind of thing. Like I don't like to pay attention to indentation and all that. So then if I hit Control Shift F, it cleans it up. So you don't have to worry about typing tabs and this and that. It's nice feature, right? You want your code readable, but you have your own style, and this brings a little bit of uniformity, and your colleagues will like that when they can read the code. So now I have, let's see if we can open. So I'm going to upload all of this, by the way, in case if you're not able to keep up, that's perfectly fine. This will be the project that you can work off of, or put code in this or borrow code out of this, whatever it is. So now I have a driver, right? So I'll create file IO instance. And since I'm working with I'll pass the name of the file. What happened to that? Okay? But I don't have, so what I should do is, in file IO class, I should create a constructor, and I'll pass it file name. And do you guys know about this keyword? Did we cover it?
Yes.
You all know what it is? Okay. Is that a question or a rhetorical question? So so f name is an instance variable. It can be used anywhere in the class, right? F name is also a local variable that can only be used in this method. So by using this, I'm referring to the instance variable. Because fname in file IO has limited scope. Fname as an instance variable has scope in entire class. So Java allows overlapping variable names in the scope, right? So if I'm trying to, if I say fname equals fname for file name, right? It's going to assign the value to itself, because when I say fname, you can see the two that are highlighted. But I want to get the value to the instance variable, so it can be used in read data method.
Oh, okay. So if you want to use it, if you want to call it the file IO, like you're going to call it there, then it can come and use there. In that
Right.
variable. Okay.
So if I say this dot fname, then what it's doing is, it's saying for the current object, take the value that is being passed in and put it in the instance variable.
Okay.
I can avoid all this by just saying that, which is easier, right? But then I will not get to talk about this. And I like to talk about this. Get it? Everyone is okay? All right. declare a variable, what do? Always. Or you can write a default constructor. Do I need a default constructor for file IO? Should I? If you decide not to write a default constructor, then make sure you say none. Right? Okay. So now at least one thing I want to see is, this is doing a print line, right? Of every line that I read. So in my driver, that's what I've done. So let me run this program. It said terminated. It didn't do anything. It took the file name in file IO, right? And then it tried to open the file. It didn't report any problems, but it didn't also print anything.
You don't have anything, data info?
I do. Well, the thing is that fname and file name, right? So the wiring is not done. This is what I call when the wiring is not done properly. I'm trying to use fname for the file name, and I also ended up adding this earlier, which I don't need, right? So when things aren't connected, obviously it's not going to work, right? So I'm saying open a null, and it's saying, okay, I'll open a null. Null is null. I'm not going to throw any exception. So I got to get rid of this, and now I need to complete the wiring. And you guys see, right, how when you use a variable name, you can sort of see in the IDE all places where it's used. That's really nice because for debugging and readability, it's really cool, right? So nothing. Now what happened? Yeah? It still didn't do anything. I just opened the file. There's more wiring to be done, no? I have to call the read data method. So we'll say a1 dot read data. And this is going to return a franchise. So I need to make a franchise B F1 or whatever. You guys will probably use more fancy names, right? So maybe now, aha, it read the line. When the wiring is done, meaning I'm calling the methods properly, life is good. We will continue after these messages in 10 minutes. Okay? See you at 7:04. What messages? I don't know.